Graphing using intercepts. 4.3 algebra. How many points are needed? Minimum number of points needed to determine a line, everyone? 2 points. 2 points. Okay. So today we are going to learn a second method of graphing. The first method was using a table. Today we're going to use our intercepts. We are here to demonstrate what an intercept is. So we have brought out the trusty football. We are in football season this fall, right? And I have a couple of football players here to help demonstrate this. So if I was a quarterback and I was attempting to pass to my receiver Ryan over there, then Jimmy on the opposite team might be trying to intercept the ball. So let's see if you can show us what that means. Okay, now I'm going to go to my other receiver, Jimmy. Not that he couldn't have intercepted, but he did stop it from getting to Ryan. And so here we go. See if Ryan can do it. Interception. There it is. So, intercept means to cross the path, right? Cross the path. There's a point where a defender, actually, is crossing the path with the ball and taking over possession, hopefully, or at least knocking it down. I mean, if it's an interception, they're taking over possession, right? So an x-intercept and a y-intercept are special points that are crossing a special location. And so what location do we find all x-intercepts at? They are all on the... Lauren, they're all on the x-axis. They cross the x-axis. Whoops, I don't want to show you that. The y-intercepts are points on the where the line is crossing the y-axis. All right, so let's take a look at this coordinate plane here. And if I'm a point, any point at all on the x-axis is here. If I'm a point on it, what do all of these points on the x-axis have in common? So somebody give me the coordinates of this point right here. Somebody up front, can you see it? What are the coordinates, Casey, what are the coordinates of this point right here? -2 and fly 2? Fly 0, right? And then this point out here. It's way out, you walk 8 and then you fly how far? You fly 0. So what do all of x-intercepts have in common? Look at the numbers. 0. Look at the coordinate pair. They all have no flying, right? 0 is the value of their y-coordinate, right? Any point on the x-axis has 0 for y. You fly nowhere. You just sit on the x-axis, right? Now what about the coordinates for your y points? If you're a line and you're crossing here, what coordinates does that point have on the y-axis? Can anyone up here see that? Christina, can you tell us this point here?
It's 0, 4.
Good. And if I'm a different line coming down here, like that, this point that's crossing the y-axis again is at, anybody up here?
0, -4.
And it's actually, I think, -3. So do we see that if you're a point on the y-axis, you are always going to walk nowhere, have a value of 0 for your x-coordinate, right? Walk nowhere, 0, and fly somewhere. Fly somewhere on this y-axis, okay? Let's find the x and y intercepts when given an equation. Here it is, 3x plus 2y equals 6. Now we could go graph this and find the points that are touching the x and y axis, but we could also just do this mathematically. And most students like to do it the fastest possible way. And the fastest way is mathematically. Okay? we simply put little order pairs like this together, right? We need to find the location where when x is 0 and you're flying somewhere, this is your y-intercept, right? And we need to find the location where if you fly nowhere, you only walk on the x-axis, you fly nowhere. So this is your x-intercept, simply by substitution. Okay, so who can read the equation when we have substituted 0 for x? Can you read that? Substituting, Sabrina? So she's plugging 0 right in, and she's calling that 0. Good. So 0 plus 2y equals 6. So just 2y equals 6, right? And so how do we find y? And what do we have? Y equals 3. There it is, 3. We found it. Walk 0, walk nowhere, and fly 3. So again, this is our y-intercept. To find the x-intercept, we're just going to substitute 0 for y this time, right? Who's already done that? Wow, good job. About 10 people have already done that. So we substitute 0 instead of y, right? So 3x equals 6. And so x equals 2. And we can put it right there, and there is your x-intercept. Okay? So if you are just asked to locate the x and y-intercept, do you see how easy that is? Yeah. You just substitute 0 for x or 0 for y and find the other coordinate. Okay? Nico? Let's go ahead and find the x and y-intercepts for these two equations, and pause the video, find them, and come back and check your work. All right, so we simply substitute and then find x and y-intercepts. Notice we take the answer we get, like y equals -5, and put it in where y is, right? Y is -5 when your x value is 0, okay? And x is 2.5 when your y value is 0. So make sure you're plugging them into the correct position there. Notice we didn't even have to put these equations in function form, right? We just left the equation in its original form, substituted, and then isolated what we needed to isolate, okay? So we're going to use this now to take it the next step, and that is you find the intercepts, and how many points do you need to draw a line? 2. Only 2, right? So we'll plot those 2, and we'll draw the graph, okay? We'll use them for graphing. So let's graph 6x plus 7y equals 42. 6x plus 7y equals 42. And we're using intercepts to do this. Okay, so once again, we're going to plug in 0, find the y-intercept. We'll plug in 0 for the y and find the x-intercept. So again, this is in the x position, so I'm going to write 6 times 0 plus 7y equals 42 over here, which means 7y equals 42. And Bailey, what's the operation we need to find y here? Good job. And y equals 7 times what is 42? Good. So we plug it in here. Look at that. There it is, 0, 6. I can go to my graph, walk 0, fly 6. And I put the point on. Okay? Now we're going to find our x-intercept by plugging in 0 for the y. So 6x equals 42 in this case, right? So, Brandon, what do we do to find x right here?
We have to divide 6 by x, and it would be 7.
X equals 7, so we put it in our little ordered pair. Now we go plot that point. We walk 7. 1, 2, 3, 4, 5, 6, 7, and fly 0. And there we have now 2 points. We said that that's all you really need to graph the line, right? That's the bare minimum, 2 points. And to show all of the solutions now, we would draw a line, straight line through and beyond. And there you go. Graphing with 2 points. Okay. What is the danger of graphing with 2 points? Michaela? Your math could be wrong. And if your math is wrong, your graph is absolutely wrong. For sure. Isn't that a bummer? Okay. So this is why sometimes people like to go back and test in between points to see, was that one really true? You know, make sure it's correct. And so there you go. Questions so far? It's kind of fun to graph with. You don't need to write this question down, but I want to offer you this question and have you think about it. Identify the x-intercept and the y-intercept of the graph shown at the right. Sometimes if we haven't talked about it, people get very perplexed, like, what do you mean? All you're being asked to do is use that graph to find that location where the line is crossing the x or the y, right? So can you do that? I mean, the x-intercept, look at it, everybody. Each blue line represents 1 unit. So where is that line crossing the x-axis? 3, 2, 1. -4. So we could write it like this, right? -4, 0. The other way sometimes you'll see it written is the x-intercept equals -4. If it's written like that, we know that the y value would be 0 because it's an x-intercept. Do you understand? So sometimes it can be written with a single number like that. And then the y-intercept, everyone, 3, 2, 1. 2. So we could write it as an ordered pair, 0, 2. Or you could say the y-intercept equals 2. And everyone knows the x value would be 0 because it's on the y-axis. Okay? There's your assignment.